Welcome to doassignment-ca. Here's the problem. As a body is projected to a high altitude above the Earth's surface, the variation of the acceleration of gravity with respect to altitude y must be taken into account. Neglecting air resistance, the acceleration is given by a equals negative g-naught times r squared over the quantity r plus y, all squared. Here, g-naught is the constant gravitational acceleration at sea level, r is the radius of the Earth, and the positive direction is measured upward. Given g-naught equals 9.81 meters per second squared and r equals 356 kilometers, determine the minimum initial velocity, the escape velocity, at which a projectile should be shot vertically from the Earth's surface so that it does not fall back to the Earth. The required condition is that v equals 0 as y approaches infinity. Now let us work through the solution step by step. The acceleration can be rewritten using the chain rule as v times dv dy. Substituting the given gravity formula, we get v times dv dy equals negative g-naught times r squared over the quantity r plus y, all squared. Separating variables, we place v dv on the left and the gravity expression times dy on the right. We then integrate both sides, the left from initial velocity v0 down to 0, and the right from y equals 0 to infinity, applying the escape condition. The left side, the integral of v dv evaluated from v0 to 0, gives 0 minus v0 squared over 2, which equals negative v0 squared over 2. For the right side, integrating the quantity r plus y to the negative second power gives negative 1 over r plus y. Evaluating from 0 to infinity, at infinity the term vanishes. At 0 it gives negative 1 over r. After simplification, the right-hand side equals negative g0 times r. Setting both sides equal and solving for v0, we get v0 squared equals 2 times g0 times r, so the escape velocity is the square root of 2 times g0 times r. Converting r to meters gives 6.356 times 10 to the 6th meters. Plugging in 2 times 9.81 times 6.356 times 10 to the 6th equals approximately 124,700,720. Taking the square root gives about 11,167 meters per second, or approximately 11.2 kilometers per second. This is the escape velocity. As a check, this matches the classical escape velocity formula derived from energy conservation, confirming our result. In summary, by writing acceleration as v times dv dy, separating variables, and integrating with the condition that velocity reaches 0 at infinite altitude, we find the escape velocity to be the square root of 2 times g0 times r, which equals approximately 11.2 kilometers per second. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.